Okay, so look at this question. Find your integral for x squared e to x dx. Firstly, we check, do we have this special form of integration where e f x, at the side here we have differential function. So power will be your fx to x. When we differentiate it, we get 2, but we get x squared at the side, so we don't have that pattern. Alright, means this integration cannot solve by using formula only. So it need your integration by part, technique of integration. Why integration by part? Because we have two different functions, where x squared is your polynomial. This one is your exponential. So by integration by part, you have to identify which one will be your u, which one will be your dv. Then you find your uv minus integrate v du. So u selection will be priority for log part, log polynomial, so x squared. Then dv will be the rest of it, which is e2x dx. So for u, differentiate u with respect to x, du will be 2x dx. Meanwhile for dv, integrate both sides so that we can find the constant v. Integrate 2x, it will be e2x over 2. Then back to the question, write your questions, and then substitute u times v minus integrate v du. So 2 can be simplified. Now you integrate x ex dx. So when we're having x dx dx, we need integration by part again. Alright, so from integrate x squared ex, now we come to x squared e to x. So to integrate x e to x, again we perform by part. What is your u? What is your dv? X will be your polynomial, then e to x dx. Differentiate u with respect to x, we get du equals to dx. Then this integrate both sides, we get e to x over 2. So we solve this integral before we substitute back to the main question there. So uv minus integrate v du, which is dx. Then 1 over 2 we can take out. Integrate e to x over 2, then plus c. So we take this answer, substitute back. Then lastly we plus c, and then we simplify this negative as a coefficient. Negative become positive. Alright, so that will be your first part. Then when we come to second part, the question says, find the volume of the solid generated by the area bounded by the curve line x0, x1, y0, and rotate 2 radian about x-axis. So when you find your volume rotate about x-axis, it means that your formula will be in terms of integration respect to x dx. So a and b and your graph here function in volume need to be square, finding volume. So we need to find out what is your region bounded by the graph x0, x1, and y0. So to draw this, if we can't identify what is the shape of this, we use our calculator to plot the coordinate so that you can know that where's the coordinate going, then you know that the graph, where the shape of the graph. Alright, so obviously you want between x0 and x1 and y0. So our graph, x0 is this, then x1 is this vertical line, and then another line is y0. So y0 is your x-axis. So what will be our graph for y equals to x, e, x? We use our table mode here, number 7. Plug in our function, alpha x, e, alpha x. And then start with the coordinate 0 because we want to concern about the area around here. So we're not concerned the area bounded after 0 or more than 1. Alright? So start from 0 and then ending I put 1. The step here. The step here, if I put 0, 0.1, I will having 10 coordinates, is it? So it's supposed to be enough for us to plot. Let's say when x0, 0, so I know that my graph is start from here. Then when x is 0.1, 0.2, 0.3, 0.4, 0.5, and so on, the graph is moving 0.1, 0.2, 0.4, 0.5 is going up, 0.8, then 1, 1.5, so suddenly it will shoot up from 1 up to 1.4, then 1.7, then 2 point something. So you can notice that your point is going up. It's not linearly because it will suddenly shoot up. It's not linearly because you can see the scale, they are not consistent. Like this one is 1.4 to 1.7 is 0.3. But 1.7 to 2.2 is 0.5 already. So it will be shoot up. Alright, shoot up until the last one will be 2.7. So we can guess that, okay, our graph for this function, it will be in the curve going up. Alright, so we can guess the shape of the graph. It will be in the shape of shooting up. Shooting up curvely. Alright, so the region bounded from x0, x1, y0, and the graph will be this region. So this is the region that we want to find for the volume. Alright, so when we look at this region, you can see it attached to x-axis. And the question also asks us to find this volume according rotate to x-axis, right? So we will see this region vertically, and this is one curve. The curve straight away bounded to the x-axis. Therefore, our volume formula, it will be integrate, start from the lower limit, 0. So volume start with formula pi. No matter how much the angle or degree they want to rotate, it will be start with formula pi. Although here they say they rotate 2 pi, 2 radian. How much they rotate also, the formula will still maintain as pi only. Alright, don't change it to 2 pi. Don't change it to 2 radian. Alright, then our lower limit 0 until upper limit 1, the function x, ex. When we're finding volume, we need to square, then dx. So we simplify our function. When we square, it will be x squared e to x. Then we look back to this integration, x squared e to x is the question start from the first part. Finding this integration, x squared e to x, it gives us this as a final answer. So we substitute the answer that obtained from the first part, which is x squared e to x over 2 minus x e to x over 2 plus 1 over 4 e to x. So plus c no need because when we come to volume, it's a definite integral. We have upper limit and lower limit, 1 and 0. Then what do we do with the limit? We write it, substitute upper limit minus lower limit. So it will be 1 e power 1, 1 e power 1, 1 over 4 e power 1 minus 0 times any function 0, 0. But this is 1 over 4 e power 0, not necessary to be 0. Here, 0 times exponential 0, 0 times exponential 0, but 0 when we substitute here as a power, not necessarily it will be 0. Power 0, it can be 1. Alright, so simplify this. What can we see here? 1e minus 1e, finish, right? So this is remaining 1 over 4e, and then plus 1 over 4. So if you want the pattern of the final answer, the 1 over 4 they factorize. So inside here just remaining, this one is 2 times 1. So e2 plus 1. Alright, so we have writing mistake here. This is supposed to be 1 times 2, 1 times 2. Minus unit cube for volume.